Our today's topic is free body diagrams. So what are free body diagrams? They are used to represent they are used to represent external forces. They are used to represent external forces on a system or a body. Now, forces are of two types. One are contact forces, where the body needs to be in contact, and another are non-contact forces. The best example for non-contact forces will be gravitational force. The best example will be gravitational force. The reason, even if a mass is in not contact with Earth, then also Earth will apply gravitational force on it. And contact forces are, we'll basically learn tension force, then we'll learn normal force, then we'll learn spring force, and the most important will be the friction force. So we'll basically learn tension, normal, spring, friction in contact forces, and for non-contact forces in this class will study only up to gravitational force. So let's discuss gravitational force first. So any mass on earth will experience a force in downward direction, and the force will be mg, and the force will always be in the downward direction only. So any mass will experience a force mg in downward direction. So this is gravitational force. So for non-contact forces, we'll only learn gravitational force in this class. Now let's come to contact force. So the most important contact force for us will be, first will be normal force. So what is normal force? So let's write down the properties of normal force first. The first property is it is applied perpendicular to the surface, and when it acts between two bodies, acts between two bodies in contact. So if any two bodies are in contact with each other, then normal force will act between them. It is a push force. It is a push force. So let's understand how it is applied. Suppose suppose we have a table like this. Suppose we have a table, and suppose a mass m is sitting on the table. So I want to draw ability of this mass. So mg will act downwards, and normal force will act since mass is in contact with table. So the table will apply a normal force perpendicular to its surface, and it will be a push force. So it will be in upward direction. So this will be a normal force. So normal force will act like this, perpendicular to the surface and push force. Okay, let's take one more example. Suppose we have one wall here, another wall here. So this is one wall, this is another wall, and a mass m is sitting here. So I want to draw free body diagram of this mass. So mg will act downwards. So the mass is in contact with this wall also and this wall also. So this wall will apply normal force in this direction. Suppose this normal force is in this direction, and another normal force will be in upward direction. So another normal force will be in upward direction. So one normal force will be in this direction, another will be in this direction, and mg will also act. So this is how we'll draw free body diagram with normal force and gravitational force. Let's take one more example. Suppose that I have, suppose this is one wall, this is another wall. Okay, and suppose these are two walls, and suppose we have two mass. This is mass m1 and this is mass m2, and I want to do free body diagram. So for mass 1, if you'll see, m1g will act downwards. This wall will apply suppose n1 force, and this will apply n2 force. And see, m1 is also in contact with m2. So one normal force will be like this. So we'll have this N1 from side wall, this N2 from below wall, and this N3 from the mass which is placed above, that is M2. Okay, similarly for M2, if I'll draw FBD, so M2G will be definitely be there. Now here you have to think about Newton's third law. So M2 has applied N3 on M1, so M1 will also apply N3 on M2 due to Newton's third law. So M2 has applied N3 force on M1, so M1 will apply N3 force on M2, Newton's third law. And suppose the normal force from this wall will be N4, so this will be N4. So this is how you have to draw free body diagrams when normal force and gravitational forces are involved. So if there is mass, then gravitational force will always be there, and if the bodies are in contact with surface, then normal force will be there. Remember, normal is a push force and it is applied perpendicular to the surface.